Last section we learned what a rational function is, okay? And now we will learn about the vertical and horizontal asymptotes, right? And how to find them. And now we will learn how to graph one of them. So let's suppose we want to graph this. So let's first call it y. So general idea is whenever you want to graph something, you want to find the y-intercept and the x-intercept, right? I mean that useful for any graph, linear or quadratic, right? But here, in addition to that, you need to find out vertical asymptotes and horizontal asymptotes if there are, and some extra points also. So the way I recommend people to do is first go in order. Let's find the y-intercepts. So find the y-intercept is generally very easy. Just plug in x equals 0, and when you plug in x equals 0, you get 3 over 0 minus 2, which is 3 over 0 minus 2, which is what? 3 over 0 minus 2, which is 3 over negative 2, which is negative 3 half. So that's your y-intercept. Now to put x, how do you find x-intercept? Well, what you do is you take y equals 0. So when you put y equals 0, you will notice that this becomes 0. And you multiply both sides by x minus 2, right? And then this becomes 0. So you get 3 equals 0, which is not possible. So that means there is no x-intercept. No x-intercept, right? And then we want to find the vertical asymptotes, and we know that to find that, you take the denominator and set it equal to 0. So x minus 2 equals 0. X minus 2 is a vertical asymptote. How do you find the horizontal asymptotes? Now you check the degrees. Are they equal? Are the top bigger or the bottom bigger? Here the bottom is bigger. And then we know from the last section that the degree of the bottom is 1. So the horizontal has to be the x-axis. Now, the way I generally recommend students do is the extra points, do not find them yet. Okay, find them as you proceed. Okay, so what I would do is now I look at the graph. Okay, so now look. So if I draw this graph, the first thing that I do is so let's try to draw the graph, the same graph, but a little underneath, right? So that you know how I start, right? Okay, so I put the y-intercepts, which is what? So about negative 3 halves, about like that. Okay. There's no x-intercepts, right? Okay. So I can put like 1, 2, 1, 2, 3. Okay. So and the vertical asymptote, there is a vertical asymptote as x equals 2. So x1, 2. So that's vertical asymptote there. And what's the horizontal asymptote? So so what I first did was I labeled the y-intercept, and then I looked for x-intercept, no x-intercept here, right? And then I labeled I put a vertical dotted line next to the y-intercept, and I put a horizontal dotted line next to the x-intercept. Now I'm ready to draw. So what I'm going to do now is I must make sure that I start with the left corner at the horizontal intercept if there is one. So this has a horizontal intercept, and where is that? This. So it can either go like that, or it can go down like that from infinity. Now, which way will it go? It can't go up because it has to cross the y-axis at, this is like a puzzle. It's very interesting actually. So it has to cross the y-axis at negative 3 halves. So if it goes up, right, then it cuts the y-axis somewhere else because it has to go to infinity at the vertical asymptote. So it has to go to infinity. The question of whether it goes down like that and goes up like that, it has to go down because it has to go through this point. So what you do is you start this point and you kind of go like that, okay? And then once it goes to infinity on the vertical asymptote, it has to come out from either the top or the bottom. Now which way is it going to come? We don't know that because it can go like that or it can go like that. Which way, we don't know. So that's the place where I find an extra point. So I can kind of nail that if I know the value at say 3. If the value is positive, then it has to go like that. The value of 3 is negative, it has to go like that. So what I do is I go and plug in the value of, well, I also put in the negative 2 just to make sure that I get the right one. So I mean, so right now I'm putting so you can see that when you put negative 2, you get a negative number. So it's a negative, so it has to be negative. But when you plug in 3, let's see what happens. So the function is 3 over x minus 2. So you plug in 3, you get 3 over 3 minus 2, which is 3 over 1, right? which is positive. So the value at 3 is positive 3. So which is somewhere here, which now shows that it cannot go down from here. It has to go past that and go up to infinity. At infinity, it goes along the horizontal asymptote. So that is how we got this graph. Okay. Let's do another example. In this case, we have 4x plus 1 or 2x. Again, this is a function. So let's find the x-intercept. To plug in x equals 0, you get 0, 0, you get 1, right? 0 plus 1 is 1, 0 plus 1 is 1, 1 over 1, which is 1, which is 1, okay? And now, how do you find the x-intercept? Well, we set it equal to 0. And when we set it equal to 0, right, once again, you can multiply both sides by the denominator and this becomes 0. And then you just have the top. 4x plus 1 becomes 0. And when we solve for x, you get x equals negative 1/4. So we have an x-intercept at negative 1/4. Vertical asymptote, you take the denominator and set it equal to 0. And we do that. 2x plus 1 equals 0. 2x is negative 1. X is negative 1/2. And so we have a vertical asymptote at x equals negative 1/2. How about the horizontal asymptote, right? Now in this case, we notice that the degree of the top and the bottom are equal. And then what you do is, when we do that 1, 1 equal, we take the leading on top or leading on bottom. So we have 4 over 2, 4 over 2 and 2. So y equals 2 is a horizontal asymptote. And extra points we can delay later. So what I did was, as usual, I put, so let's once again try to draw this on the sides, right? Okay. And then you will see how this happens. So the y-intercept is really 1, right? Okay. So y-intercept is 1. Note that. And then x-intercept is what now? Is negative 1/4, right? So which is what? Something like this, very close to 1, negative 1. So we have 2 points. And now what? The vertical asymptote. Vertical asymptote is negative 1/2, which will be somewhere here. And we have horizontal asymptote, which is 2. So kind of up there, right? Okay. Like twice the distance. So we have 2 here. So now we'll start our journey. Now we start at the horizontal asymptote, and then it has to either come down like that, or it has to go up like that to infinity. Which way did it go? Now we don't have any points there, so we need a point somewhere here, okay, before the vertical asymptote, right? So we know that the vertical asymptote happens at a negative 1, right? Okay, so sorry, negative 1/2 actually. So the vertical asymptote, this is negative 1/2, right? Okay, so that's our vertical asymptote. So what we do is we can take negative 1, which is kind of here, and from that we can find. So if we plug in negative 1 to the equation, right? And then you have 4 times negative 1 plus plus 1 over 2 times negative 1 plus 1. Get negative 4 plus 1, which is negative 3. Negative 2 plus 1, which is negative 1. So it's positive. So the value is positive 3. So really that is up. So because this is 2 here, right? So at negative 1, it actually goes up, which actually means that after the horizontal asymptote, it has to go up like that. Right? That's why you go up like that, and then it comes down. Why? Well, it comes down because you need to go through these points, right? Okay, it goes up like that, and then it comes down, and then goes like that. Okay. And why doesn't it come from the top? Why can't it come from the top? Because it has to go through these 2 points. And after that, it has to keep going until you get the horizontal asymptote. So you start with the horizontal asymptote, right, and end with the horizontal asymptote. But you need to have an extra point to figure out in the journey between the horizontal asymptote and the vertical asymptote, whether it's going to go up or whether it's going to come down from the bottom. Okay. So that's it for this video, right? And you can actually see the graph in a much better way. And we will do slant asymptotes in the next video.